Hello, and welcome to Gaming at Planet Scale with Google Cloud. I'm Rob Martin, Chief Architect for Gaming, and I'm joined today by Ed Wu, Vice President of Data Analytics at Niantic. Let's start by taking a look at the massive growth in gaming. $177 billion in global revenues, and that number is expected to exceed $200 billion in just a few years. So things have really been accelerating in gaming. But then in 2020, COVID hit. Social distancing and remote work became a must. What would it mean for the gaming industry? As the world went into lockdown, gaming offered a much needed respite as people sought community through games. Just take a look at these numbers. Dramatic increases in revenue and daily user engagement, and explosive growth in crossplay and streaming. As we looked more closely at this growth, we noticed some interesting trends. Gaming is diversifying, with growth among women, married couples, and grandparents outpacing the general trend by double-digit margins. And new parts of the world are also joining the fun, including the Middle East, across APAC and EMEA. But these new players in more geographic locations have different expectations about the types of gameplay experiences they desire. With more powerful hardware, novel new device formats like AR and VR, and global networks, player expectations are on the rise. Players want to experience their games anywhere, picking up their progress on whatever device is handy. They want to take their games on the road with streaming technology. But a more fundamental shift is happening. Game experiences are moving from short, stateless matches for competitors to persistent, long-lasting worlds and metaverses in which creators rule the day. These shifts in expectations require new thinking and new solutions. As a game developer, you now need to be thinking at planet scale. Google Cloud can help you planet scale your infrastructure, planet scale your audiences, and planet scale your studios. First, let's look at serving player audiences at planet scale. The data shows that growth in gaming strongly favors multiplayer titles. Look at these exponential increases in engagement for multiplayer and competitive experiences. Multiplayer games are the most played games, and they're also the most watched games. To reach these competitive audiences at low latency, you need data centers distributed around the earth. And Google Cloud has 27 regions to serve your players and almost 150 network edge points of presence. We're continuing to expand our regions into gaming hotspots like Seoul, Warsaw, Doha, and Santiago. But you need more than just data centers for a world-class player experience. With Google Cloud, you get access to our global fiber optic network, the one we built for YouTube, to provide your players with the highest possible quality of service. As we look forward, we're partnering with major telcos to expand our global footprint from dozens of cloud regions today to thousands of telco edge locations tomorrow. So your network is future-proofed and ready for AR, VR experiences and the metaverse. So planet scale infrastructure is critical to the expansion of your games. But as a global citizen, you need to be mindful of the carbon emissions these resources can create. Google Cloud is the only cloud provider that has been carbon neutral since 2007, 100% renewable since 2017, and will be 24/7 carbon free by 2030. So let's pivot from infrastructure to gaming specific services. Google's strategy for gaming services is simple. We partner with top industry players like Ubisoft, Unity, 2K Games, and Embark, and co develop open source gaming solutions. Together, we bring you planet scale without the lock in. Now, everyone knows that the most important day in a game's life is launch day. Google Cloud's team of game launch experts can help ensure your launch day is smooth and error free. There's no better example of launch success on Google Cloud than Apex Legends, which our team took from 0 to 50 million players in less than a month. We'd love to do the same for your game. But as gaming has grown, hacking and distributed denial of service attacks have grown too. Gaming is the #1 most attacked industry, and we're seeing a 5x rise in DDoS attacks just since last year. Google routinely fends off the largest DDoS attacks in the world, like this 2.5 terabit per second attack, which is the equivalent of aiming tens of thousands of 4K video streams all at a single server. Google's network edge is designed to seamlessly absorb this scale of attack. With Cloud Armor, we're making this DDoS mitigation service available to you, including protection for all of your workloads, including UDP game servers. So you can rest assured that as your games grow, you have planet scale protection in place for your players. Speaking of players, let's shift to taking our audiences to planet scale. Remember that as gaming is growing, the player base is becoming increasingly more diverse and more casual. Each of these new player types has different preferences on how they prefer to be monetized. Some players opt for ad-supported games. There are challenges in this space given IFDA, but ads are still important because in some markets, players are less likely to pay. Games as a service powers the most profitable games on mobile and is now moving into console. All world-class studios must deeply understand their audiences at a cohort level. And with the emergence of the metaverse, it's important to build economies for both players and creators with scalable and reliable microtransactions. As you know, Google's ability to process data at planet scale is unsurpassed. And with Google Cloud, that power is put directly into the hands of your data analysts and data scientists. We're building solutions that simplify machine learning with dramatically less code required. And we're bringing exaflop scale to ML inference, which will allow you to integrate real-time insights directly into your game. BigQuery, as the core of our data processing capability for gaming, is powerful enough for the world's largest games out of the box. With built-in machine learning, your developers can build powerful ML models with just a few lines of SQL. This unlocks the ability to integrate real-time insights, mitigate disruptive behavior, and adapt gameplay to player preferences in real time. So with the ability to ingest and process data at planet scale, you also need to surface those insights for your team, from creatives to executives. Looker brings you intuitive, real-time dashboards made specifically for gaming. Now let's take a closer look at how disruptive behavior like harassment and toxic speech is affecting players. These behaviors are on the rise just as newer, more casual players are trying games for the very first time. At Google Cloud, we're addressing disruptive behavior with machine learning, which can detect and flag this behavior at worldwide scale. Stay tuned for more in this space. As we wrap our focus on audience, there's no better example than King, who engages with over 250 million players a month and processes close to 100 billion events every single day. Truly planet scale. So, finally, let's talk about how Google Cloud can help take your studios to planet scale. COVID has been a really challenging time for developers and creatives, and it has highlighted the industry's unsustainable dependence on access to on premise workstations and hardware. We've been asked by publishers, is it possible to box up a game studio and deliver it remotely via streaming to any device anywhere in the world? That's exactly what we've developed with our virtual studio solution. Virtual Studio deploys the critical infrastructure of a game studio, including storage, version control, and workstations in the cloud, and delivers this content via streaming. This allows you to source the best talent wherever they are the most productive, including in tax advantaged locations. We recently announced our partnership with Epic Games for the Unreal Fellowship program. Together, we've helped thousands of students build their skills with Unreal Engine, all without requiring access to physical hardware. With Google's layered approach to security, including a secure private network and purpose-built secure hardware, you can rest assured that your intellectual property is safe. So we've talked about how Google can help you planet scale your infrastructure, your audience, and your studios. Now let's talk about practical experiences running games at planet scale. It's my pleasure to introduce Ed Wu, Vice President of Data and Analytics at Niantic. Thanks for joining us today, Ed.
Thank you so much for having me, Rob.
Absolutely. Can you tell us a little bit about yourself?
Sure. I lead and manage the data science, the data engineering, and machine learning teams here at Niantic.
Awesome. Well, many folks that are watching today are probably very familiar with Niantic, but we'd love to hear your perspective on what Niantic does and about some of the games that you produce.
Absolutely. We, at our core, our products are about inspiring people to explore the world together. And we're probably best known for our product Pokemon Go, which helped build and create, uh, uh, and which we launched about 5 years ago. So I've been with Niantic for about 9 years. We spun out from Google about almost 6 years ago in order to create Pokemon Go and the set of experiences that we have today. And when we spun out, we started out with only 7 engineers. We've grown significantly since then. And as we launched Pokemon Go, we were able to bring our mission to hundreds of millions of people all around the planet, turning that game into a global phenomenon, which still is one of the top consumer experiences today, but also in the process, launching a platform and a set of games on top of that platform that we are bringing to market now.
And it really is a global phenomenon. I mean, Pokemon Go is a household name. So really cool to, I imagine, to have been a part of launching that and seeing what it's become. In the talk earlier, we talked a little bit about, infrastructure at planet scale. And I imagine that a game like Pokemon Go, especially when you launch it, there are some really interesting infrastructure scaling challenges that come along with launching a global phenomenon like that. Could you tell us a little bit about what it was like to launch Pokemon Go?
Absolutely. So we at Niantic, we conceive of planet scale a little bit differently, which is we really conceive of the Earth as a single real world, single experience, right? And the experiences that we want to create on top of that, the technology that we want to use to augment that to really be, again, a single world experience where all the people who are playing our experience interact in a single coherent world. From a computer science perspective, that has a ton of n squared kind of problems to it. But uh, uh, what we were able to do in launching Pokemon Go was build a set of algorithms that could power past those limitations and create a single shared universe where when one person saw a Squirtle down the street, the dozens or hundreds of people around them could all towards that Pokemon and experience the joy of experiencing that together. And so, uh, uh, what we what we needed to build all of that out was not only a set of algorithms that could build a single coherent server, but also infrastructure that could scale elastically to meet the demand of literally hundreds of millions of people who wanted to play this game not only at launch but through to the current day.
Yeah, I think just about everyone remembers, the experience of finding their first Pokemon. It's almost like a magical experience, and it's really, to me, it demonstrates the power of taking, really advanced software like Niantic writes and combining it with cloud scale infrastructure and the types of things that you're capable of doing.
Absolutely. And a big part of that magic is discovering those Pokemon in the real world with your friends and family. And uh, doing that requires network and a scale and a single world infrastructure that GCP has helped enable us to have.
So one of the really interesting things that you all do is the Go Fest, where you have live events that happen around the world that players can all join in on together. And I imagine that creates some very unique scaling challenges as well for the infrastructure that runs Pokemon Go. Can you tell me a little bit about that?
Absolutely. I think there's two really unique types of technical challenges that this creates. The first is really created when we have tens of thousands or even hundreds of thousands of people show up in the same place around the world, in one of these cities around the world where we've conducted live events in the past, such as Chicago or Dortmund, Germany. Uh, in that instance, our single world geospatial algorithm has to be able to handle a huge influx and high density of folks in one location, all interacting with the same objects with a high concurrency in that part of the world. Um, we've been able to successfully run those events, dozens of them over the past few years, as a result of both our algorithms as well as our ability to scale vertically in those areas on GCP. But in addition, we've also in the past couple of years, in response to all these global events, have run our GoFest globally and allowed millions of people to take part in an incredible weekend of going out and exploring with and finding Pokemon with their friends and family. And they do so by uh, uh, on top of our not only our algorithms but also the scalable elastic infrastructure that allows our concurrency numbers and number of users to frankly skyrocket during those weekends when we hold those events.
Yeah, and I think these types of live events are really what happens when an experience like Pokemon Go evolves from being a game to being really more of a platform.
Absolutely. And what we've always done is try to keep in mind that the goal of our technology, right, is to get folks out into the world together, to build a platform and a technology that underpins that, and which will power our next set of experiences that we have in soft launch today.
Awesome. Well, let's move on to audiences and data at planet scale. So, take us back maybe to the beginning, when Pokemon Go was launched. What was some of the types of data that were really critical to collect, to support a successful launch and to get that game off the ground?
Absolutely, it was absolutely necessary to know just how many people were hitting those servers, right? In order for us to plan and provision, right? What their engagement time was, what their retention was, what their monetization was. These are all normal business metrics that I think every mobile product or mobile game needs absolutely needs to track. Um, when we started, we only had a handful of engineers, and as a result, our data systems were really rudimentary. We were doing kind of nightly batch jobs against the entire database using Google Cloud Data Flow in really customized code to just produce a few metrics. And that got us to where we needed, but really was a far cry from where we could be. And so uh, uh, after launch, we built a system where we were able to, in a privacy first way, begin to stream data out of our front ends into BigQuery, and create a data store that we could use for rapid query and experimentation and analysis. And that data store built on top of BigQuery that we now have an entire team of data scientists working on has at its core, at its heart, a privacy first lens on on uh, integrating and retaining data, but then uh, also allowing us to really look at metrics that help us not only understand those basic things like retention or engagement, but also the metrics that we have designed in order to look at what our mission, whether we're actually living up to our mission of inspiring people to explore the world together. And so now our data scientists are able to do things like look at the aggregate number of kilometers walked that people in our experiences are doing, or look at the real world social interactions that they're having and whether that goes up or down based on changes that we're making in our products. And that's all enabled by this incredible data infrastructure that we built, again, in a privacy first way on top of BigQuery that has been able to scale out as our team has scaled.
That's really interesting. And so there was sort of an evolution from batch oriented data processing in the beginning to more real time processing now. And also an evolution from operational metrics in the beginning to metrics that are maybe more focused on player experience and that sort of thing now.
Absolutely. We really fervently believe that, well, of course, those business metrics are key to the, our health and performance as a company, uh, that those mission metrics are really what differentiate us, right? That if we follow our mission, that we are building products that really are unlike those of other companies' experiences, right? By tackling the hard problem of getting folks to actually go out into the real world and explore and do that with their friends and family, we really believe that we have a niche in the products that we create that is unique and that keeps us uh, differentiated in the marketplace. As a result, those are also business critical, but in a different kind of way.
It's super interesting. And you mentioned privacy a couple of times. And, in games, there's sort of an expectation on the part of the players that you're going to constantly be personalizing the game and providing experiences that are, interesting to as an individual. But there's also sort of this competing expectation of personal privacy. And, I'm really interested to know how Niantic approaches those competing challenges.
It's really, really important for us that we, at our core, the core of our technical systems, matches those expectations of privacy that our users have. And so, as data streams out, is immediately pseudonymized, and only the data that's necessary in order for aggregate analysis to occur. That again compute our metrics like retention or kilometers walked are kept. And anytime that we have a data store that is used for human interaction, that data has its identifier stripped from it, and only the data that's necessary in order for that set of analyses to occur is retained. But likewise, you mentioned personalization, and this is again an important part of running a modern mobile game business, right? Folks expect that the game is optimized and uh, uh, engages them in a sometimes personalized way. And the way that we approach privacy there is to ensure that if any data is going to be utilized on a per player basis, that it is only looked at and worked on by an automated algorithm or a machine, right? That if there's a explicit player identifier that needs to occur to be had in order to affect their experience, that is not something that ever lives inside a individual's laptop or BigQuery instance, right? But instead is done solely within an automatic process.
Sounds like a great way to sort of honor those two competing promises to players. It makes a lot of sense. In our final area, I wanted to touch on sort of this idea of taking the studio to plan at scale. And you mentioned a couple times that there was a very small team of maybe 7 engineers in the beginning, and now you've evolved to having data scientists and perhaps people working in different locations. Can you give us a sense for how the studio has grown at Niantic and some of the changes from those early days to the way that things work now?
Sure. When we spun out of Google, we had all of 7 engineers, and it's amazing for me to think about where we've to since then. We started out on the West Coast in the Bay Area in Seattle, but now we literally have hundreds of engineers spanning the globe from London to Tokyo. And it's been really important as we've scaled out that organization to make sure that we have strong controls on the data and ACLs throughout all the different computing instances. This again gets back to doing the right thing by our users in terms of privacy and security. And so uh, uh, I'm really glad to see that GCP over the years has also improved their ability to provide better controls across their infrastructure. Uh, uh, Abilities such as being able to tag projects and put them into folders have really made it much, much more straightforward for us to manage our organization. We have a workflow where uh, virtually every engineer actually spins up a GCP project, right? And the only way that that's manageable is by these scalable access control tools and scalable tagging and folders for GCP projects.
That's really fascinating and exciting growth, and certainly exciting to think about what's ahead for Niantic and how we at Google Cloud can help. Any closing thoughts for us?
Yeah, I think that it's been really a great collaboration working with Google over the past several years, building out uh, Pokemon Go on top of that infrastructure, but also looking forward to how we're going to continue to achieve our mission of getting folks out into the real world together by building really innovative, scalable experiences on top of the elastic computing that and services like BigQuery that you've provided.
Yeah, the team here at Google is certainly very proud of the work that we've done together and excited about what the future holds for Niantic and Google Cloud. This has been a really fascinating insight into your world, and thank you so much for joining us today.
Thank you so much for the time, and really excited to continue the collaboration together.
Absolutely. Thanks so much, Ed. At Google Cloud, we're working with top publishers and studios across the world to scale up their games, and we'd love to work with you to launch your next big hit. And don't forget that when you work with Google Cloud, we bring you the best of all that Google has to offer for game developers. I'd like to thank Ed from Niantic again and our viewers for joining us. I hope you enjoy the rest of the content at Google Cloud Next 2021.